challenge to try to recast in just 6 minutes the whole history of artificial intelligence, a story of 50 years ago, and to try to point to the future of this discipline, artificial intelligence. Initially, artificial intelligence was about replicating human intelligence. We were trying to obsess by human intelligence. And human intelligence is thinking, solving. A good example is planning. You know, when you plan, you try to anticipate the future. So you say, okay, if I'm doing that, the world will become like that, and then I can do that, and the world will become that. And I try to find a solution, a sequence of action that will bring the world to what I want. And my favorite example of planning, we are the only species in the earth to be able to plan. You can try with monkeys. There's been a lot of experiments. Monkeys cannot, for instance, plan to try to reach a banana on a sailing. They can plan to do so. And I believe because their brain is less connected than our brain. We have a densely connected brain that helps us to plan, to anticipate. My favorite example is taken from a movie, from Bruce Willis' Die Hard movie. He has a puzzle to resolve in 1 minute. This is the following puzzle. He has to, there are 2 jugs of water. One is 3 liters, the other is 4 liters. But you don't have any indication on quantity. And Bruce Willis has to fill the 4 liters jug with 2 liters. And he has no indication of quantity. An AI system, an artificial intelligence system, will do it in 1 nanosecond. Bruce Willis has 1 minute for doing that, otherwise New York would explode. And an AI system will say the word is 00, and I want the word to be 2n. How can I do that? Well, simply, you think about a set of action that you can do on the world. Sorry for that, it's just a little bit of math, it's the only thing. Any action is very simple. This is the world before taking the action, this is the world after taking the action, okay? I can fill the jug, I can empty the jug. This is an AI system, this is the way computer can reason and computer can solve this problem. The basic thing, the basic solution is to chain those actions in order to resolve the problem. And you try things, and a computer is a brute force engine, and you try, okay, I can fill the first water, I can fill the second jug, I can empty the second jug, and you try things, and you chain those things in order to find a solution. And the solution found by Bruce Willis is the following. Bruce Willis needed 1 minute to find it, the computer need just 1 nanosecond. And this is the solution. You fill the second jug, okay, then you empty the second jug in the first jug, and then you fill again the second jug, and then you empty the second jug in the first jug. And this is the magical number. This is the number 2. This is exactly what Bruce Willis was heading for. And a computer will make it in 1 nanosecond. That was artificial intelligence in the 50s, in the beginning of a computer. And this is exactly how an artificial intelligence played chess. Exactly the same strategy. They build tree, they chain action. In the case of chess player or a simpler game which is tic-tac-toe, it's a little bit more simple than chess. You try to see what can happen if you move that, and you have to anticipate also the movement of your opponent. But again, it's the same story. You have to build a chain of reasoning in order to beat Kasparov in playing chess. And obviously, a computer can build billion of those trees and can try billion of those moves in order to find the right sequence of moves. And you know that in the case of tic-tac-toe, this is the right first move to put the cross in the middle. This slide is simple. We have 2 cognitive systems. One is thinking, one is reasoning. One helps you to play chess. The other one is recognizing your mom, recognizing your lover, driving a car. It's typically different cognitive systems. Artificial intelligence has concentrated mainly on this one until the 80s. And then in the 80s, there's been a move. People realized that we had to understand how an animal can circulate in a world. We had to need to build computers that are able to be a lizard, be able to move in the world, and not only to play chess. And so in the 80s, and still today, there's been a big move in the lab, try to understand how we perceive, try to understand how we act, which is completely different than how we think. And a classical example of those AI system is called a neural network. A neural network is just like a brain. There's input neuron, which is what you perceive, and this is output neuron, which is how you act. And so we try to replicate sensory motor action, unconscious action, not conscious thinking. The best example is how you drive a car. You try to have a neural network being able to drive a car. What you do, you imitate what the human driver sees, and you imitate what the human drivers do. And you try to connect what he sees and what he does. And when you can connect it, you substitute the human driver by a neural network. And the neural network will behave exactly as a human driver. And don't surprisingly, Google is commercializing those things. Today you have autonomous driving machine. You don't need driver for those cars. And this is exactly done by a neural network. It's a completely different type of AI. No thinking, no reasoning, just imitating. Big data, you need a lot of data, the data of the driver. You need a learning machine to be able to extract the driver technique out of the data. In my lab, we're building a lot of systems like that. For instance, we have built an ant colony optimization system which is able to route message on internet, simple engine connected together, learning big data, and you have the best router strategy today on internet. Now, my favorite realization of AI, Kasparov, okay, this is old AI, still kind of present AI, the autonomous car. And this is an interesting one. Watson, certainly you've heard about it. Watson is the champion of Jeopardy, a classical game in your TV. And the AI right now is about big data. A nice example of AI is profiling human being. This is a genetic profile. You just take a lot of data. And this is a clustering of the genetic profiles. This is cancerous patient. This is non-cancerous patient. With data, you can do the medicine of the future because you personalize your medicine based on data. Not surprisingly, Google is investing a lot in big data. Just to give you an example of big data realization is Google Translation. Google Translation is not at all imitating the whole translation machine. It's just big data. Google has collecting any translation done those last 20 years, and the translation engine of Google is based on that. No syntactics, no semantic analysis, just big data and extracting information out of the big data. My favorite sentence now is Al Gore, a scientific advisor of Google these days. We're still waiting for AI to surprise us, but with big data, we might achieve that. Thanks.